Hello everyone, welcome back to my YouTube channel. So today I am going to discuss an interesting real analysis problem. So the question says that does there exist a continuous function from R to R taking every value exactly twice? You have already seen the question in the thumbnail. So actually there does not exist any continuous function satisfying this property. So today I am going to discuss this question, and I will not write down the proof rigorously, but I will discuss it using graph. I will try to visualize this problem. If you can understand it, then you can easily write down this proof rigorously. Okay. So the solution is that since f takes every value exactly twice, so choose 2 points A and B such that fa equal to fb. So graphically, if you can see, this looks like this. Okay, here is A, here is B, here FA, here FB, and FA and FB both are equal. Okay. Now observe that then for every x in open interval AB, fx either greater than fa or fx either less than fa for all x. Why? Because if not, say there exists some point x such that fx greater than fa, and there exists some point y such that fy less than fa, then by intermediate value property we must have some c in between x and y such that f of c must be the same value as we already have fa and fb, right? But it is given that f assumes every value exactly twice, but the here we get that fa equal to fb equal to fc. Okay, I again repeat it. If for some point fx greater than fa, try to see the graph. If for some point fx greater than fa, and if for some point fy less than fa, then there must be some point in between x and y such that fc gives the same value as fa and fb. Okay, so then in that case fa equal to fb equal to fc. So we have three distinct point assume same value. So this is a contradiction, right, to our given condition. So we can assume that fx is greater than fa, and that is same as fb. So fx is greater than fa for all x in between x and in between a and b, and or fx less than fa for all x in between a and b. Okay, so without loss of generality you can assume this. Without loss of generality you can assume this, J, without loss of generality you can assume that fx greater than fa for all x. Okay, or fx less than fa for all. In that case, now similarly observe that we are assuming already that fx greater than fa for all x in between a and b, right? So say fx looks like this. We are not interested about the graph, but fx is greater than fa, that is enough for us in between a and b. Okay, now observe the graph of f in negative side of, I mean in left hand side of a, and try to observe the graph of f in right hand side of b. Okay, in that case if fx greater than fa at some point, then you can see that that value already assumes 3 times. Okay, so you can see that if fx greater than fa for some point, say at this point fx greater than, so this will also the same value as this. So you already see that we have three distinct points assuming same value, so this is not also possible. Similarly, if fx is less than fa for all x, and if you have fx less than fa for some x in left hand side of a, or for some x in right hand side of b, then similar situation will arrive, right? So similar situation will arise. So that is why we can conclude that if fx greater than fa for all x in between a and b, then fx must be less than fa for all x which is in left hand side of a, and similarly for all x which is right hand side of a. And in other case, if fx less than fa for all x in between a and b, then fx greater than fa for all x in right hand side of b as well as for all x in left hand side of a. Because of, if not, then we will already have three distinct point assuming same value. Okay, that is obvious. You can see using graph that here this at this point, at this point, and at this point, 3 points already we get. Or if this part is here, this part is positive, but if the at least one part, I mean either left hand side of a or right hand side of b, at least one part satisfying the same property which we already assume in the case of the intermediate values of a and b, then it will contradict, because then it will assume three distinct, I mean for three distinct point same value will, I mean same value comes. Okay, so if assumes same value for three distinct point in that case, so it will not happen. So in that case, either the graph looks like this or looks like this. Now observe that f takes each value exactly twice, right? But if this will happen, then f will not take all values. I mean f will not be on to. F is looks like just minus infinity comma some k, where k is the maximum value attained in between a and b. Similarly, the image of f must be, if f graph of f looks like this, then image of a must be some k comma infinity. Okay, so f will not be onto, that is also a contradiction. So this is the exact reason for which we can conclude that there does not exist any function f that assumes every value exactly twice. So every value means f must be onto, as well as each value should be taken at least two times. I mean, sorry, each value should be taken exactly twice. So this is a contradiction. Okay. So the main part is that this part, for first part, you have to just think about the intermediate value property. If there is some point for which fx greater than fa and there is some point for which fx less than fa, then definitely by intermediate value property the value fa must be attained in between these two, so that will not happen. And the second case, you have to see that if fx behaves same like what fx behaves in between a and b, then also it will contradict. So finally we can conclude that there does not exist any such function. I hope you can understand it very well. Okay, thanks for watching.